time. So this is some extra practice with the same concepts. We've got two problems that are going to be about a flat surface. The first one is a frictionless surface. The mass of this object is 10 kilograms. You're going to apply a force of 12 newtons, but this time you're pushing downward. And so that's going to be 12 newtons, technically at a negative 30 degrees because it's going downwards. And you're going to push that object a distance of 1 meter, and it's going to take you 1 second to do it, and you need to calculate that power. In the next problem, this time I've actually included some friction. It's not a frictionless surface. So you're going to have to go through that thing where you had to calculate the net force when there was friction involved. Okay, we did several examples, and there was one on your last assignment. So this time we've picked up our force a little bit. It's 20 newtons, and we're also pushing at a smaller incline to get a better angle. We're only pushing at 10 degrees this time. The mu is 0.5, that's our coefficient of friction. The mass is still 10 kilograms, that's the same. We're pushing it a little farther, 5 meters, but we're taking more time to do that, 1 minute. You're calculating the power here as well. And then, we've got a force on an inclined plane. The mass of the object that's on the inclined plane is 7 kilograms. This is a frictionless surface. Both of these are going to be frictionless. And so in this one, the trick is that you actually are going to apply a force straight up the ramp. It is parallel to the surface, so you don't have to worry about figuring out any angles with your push. You're pushing 5 newtons up the ramp. So I'm calling that -5 because it's technically going to the left. Okay? You're going to push at a distance of 10 meters in 30 seconds, and you need to calculate that power. Last problem. Here's Virgil. His mass is 25 kilograms, and he is on a frictionless surface. It's like a slide, and he does not want to be on there. And he's like, meh, but it doesn't matter. He's sliding down. So he's not applying a force upward. The only force here is gravity. Okay? It's an angle of 60 degrees. 2 meters is the distance that he's going to go down, and it's going to take him 12 seconds to make it all the way down. You're going to calculate the power. And then I also want you to show that the work, which would be the step before power, you're going to show that the work done on Virgil by gravity is equal to the change in gravitational potential energy, like what I showed you in another video. So we learned that the force times the parallel distance was equal to mgh. So using that idea, I want you to do the same thing here. So this is basically exactly the same as numbers 4 through 7 on your previous homework, okay? All right, that's it. I'm done. Bye.